What's that?
The smashing machine.
What's it called?
This is a smashing machine.
Smashing machine.
It's the one with the rock. Where they made him they gave him a face and he plays a fighter.
I haven't heard a damn thing about that.
Yeah.
I feel kind of happy I've never heard of it.
It's not bad.
Really? Okay.
Yeah. It just tells the story of like a MMA fighter.
Oh, okay. What was the other one? There was a horror movie that was about the football dude.
Oh, him?
Yeah. That was another Peel. That's another.
It's just called him. Yeah.
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 Okay. I can't.
I heard it wasn't good though.
That's what I heard too, which is disappointing.
Yeah, that's what I heard. I didn't watch it. But
Considering all the other movies he's made, it's, yeah. All right. Let me kind of catch up to you guys. What's 3 to the negative 2? 1/9. 3 to the negative 1. 1/3. 3 to the 0. 1. 3 to the first. 3 squared. 9. Now you can imagine if I keep letting the numbers get bigger, positive 3, 4, 5, my outputs are going to get stupid big, stupid fast, right? Can somebody do 3 to the 6th on your calculator? What's 3 to the 6th?
729.
Yes. 729. It gets big quick. Yes?
I wish I had a time machine so that as soon as he asked it, I could just say it.
That's what you use a time machine.
Yeah. Yeah, someone did 3 to the 6 and I just say
You
it.
got a time machine, what's the first thing you're going to do with it? Gonna go back and answer a question really fast? That sounds good.
I wish I had the power to go back in time 5 seconds so that I could do that.
Jeff, what do you do with it
With what now?
with time travel or whatever?
Oh! Alright. A little funny thing about Jeff. I wrote in my physics book a little message, and I still have it. It says, Jeff, when you invent time travel, come back to this day and come into the classroom. I can't remember what I said. You know what I mean? And it didn't happen, so I'm like, damn it, I guess I didn't invent time travel. So,
Not yet.
there's a movie called I got a movie for you. It's called Time Bandits.
Okay.
You ever heard of it? Alright, I'll watch your movie, you watch mine.
Alright.
Time Bandits.
Time
It's the
Bandits.
best time travel movie. Well, it's one of the best.
What's it on?
You ever seen it?
No, I've seen
Hell yeah. Donnie Darko is kick-ass. The freaking rabbit thing? You kidding me? Alright.
time travel too.
About time travel in a trippy ass way.
Back to the future.
Oh, is that about time travel? No. That's right. Sorry. Yes, it is. I'm sorry. Alright, alright. So,
you hear about hot tub time machine?
hey, there you go.
There's your shit.
There you go. Let's see, what kind of scale do I want here? Let's do 2s, just so I can get up to 9. Alright, so 0 is 1. 1 is 3. 2 is 9. Okay. And then negative 1 is 1/3. Negative 2 is 1/9. What would negative 3 be? In fact, what would 3 to the negative 1 billion? What would that be?
Really small.
No, just tell me.
0.
What's 3 to the negative 2? 1 over 3 squared. What's 3 to the negative 3? 1 over 3 cubed. What's 3 to the negative 1 billion?
Over 3 billion.
1 over 3 to the billionth power, yes?
Sure.
Now, Braden said, let me just tell you exactly what it's going to be, Jeff. It's going to be small. And that's true. Do you all agree? I don't care how big negative the power is, the top will be 1. Yes?
Yes.
1 over some stupid big number. So can the output ever be 0? In order for a fraction to be 0, what must be true about the top? Top must be 0. We just said, however big negative power you put in, the top is going to be 1, because you're going to flip it. There's going to be a 1 up there, correct?
Right.
It never gets to 0. So what is there at 0? What is there here?
An asymptote.
There's an asymptote.
Holy crap. That was good.
Thank you. It's about time I had a good woman. All right. So then this is going to get really big really fast, and the other side gets really small really fast. but it never gets there. It's just getting closer and closer. So you can think about it like the distance between the x-axis and the function goes by 1/3, 1/3, 1/3. If I cut something in thirds forever, I never get 0 of it, theoretically.
Right.
In real life, you try to cut a pie in thirds forever, you're going to stop and just eat the damn thing. You're going to get to 0 quickly, especially this with Google Call. Okay, is everybody kind of with me? How much have you guys worked with this before? Have you guys seen that shape before?
Exponential.
Exponentials, exactly. Because math people, again, we're creative. We said, look, we put the variable up in the exponent. This called exponentials. And so that's the history. That's exactly what happened.
Continue, no, compound interest.
Oh, God. So real quick, can you guys remember, bringing this idea back, what transformations would be involved here?
Left.
Good, left 2.
Up to
Down 1. So it doesn't matter what function you're looking at. I love that you guys saw that immediately. It doesn't matter what function you're looking at. If I put a +2 next to x, it's going to go back to. It's got no, whatever function is, the transformations work exactly the same way. That kicks a lot of ass. So then I can just do that with every point. So every point would go left 2, and then down 1. Left 2, down 1. Left 2, down 1. And where's my asymptote going to end up? Yes, everything moves left 2. If I move an infinite rod left 2, nothing happened. So it only matters if it goes up or down. So I moved it left 2 down 1. So the asymptote is now at -1, which would be like right here. Because my scale is 2. Damn it. You can make whatever sound effects you want. Okay, so I just wanted to bring back an old idea. Every time you learn a new function, you can apply old ideas to it because they all work the exact same way. So a really good thing to point out, what's something else we've done with functions? We found their inverses. Okay, so just stick with me for a bit. I'm going to talk some more. We're going to do an inverse of this, and then I got a little handout. I'm not going to read it.
Yes.
But I need to get the idea across about inverses. So in order to do that, let's do a clean graph here. Clean graph. So if you do it down here, you got the graph on the back. Gonna work with. Awesome. Let me see if you guys are cool with this. If I'm gonna graph y equals 2 to the x, there are 3 main anchor points. We all know what number to a variable looks like now. It looks like this, yes? I can move it, I can reflect it, I can move it up and down, I can do all kind of shit, I can squish it, I can do all kind of shit. But it looks like this, yes?
Yes.
So I don't need 5 points, damn it. I just need 3. So there, I have my anchor points. There are -1, 0, 1 inputs. When I put a -1 in, what do I get? What's 2 to the -1? 1/2, yes. So 2 to the -1 is 1/2. 2 to the 0 is 1, and 2 to the first is 2. Yeah, boy. I obviously didn't use the scale behind this poor little dude, that's alright. Come down here, -1, -2, okay. Now we're gonna graph the inverse together. How do you graph the inverse given a graph? What's true about the inverse? What does it always do? Change x and y. It does that algebraically, it does that graphically. Thank you. So what points does this go through? So y goes through, where'd it go? -1, 1/2, 0, 1, and 1, 2, yes? So what points will my inverse function go through?
Half, -1.
1/2, -1,
1, 0.
1, 0, 2, 1. So 1/2, -1, 1/2, -1, 1, 0, 2, 1. So it's going to look like, and it kind of makes sense, it's got to be reflected around this y equals x line, yes? So it's going to look like, what's happening? Where did my asymptote go? If the original was the x-axis, and I flip everything around y equals x, the new thing is the y-axis. So there's an asymptote on the y-axis. Now what's funky is, I just graphed the graph of an inverse function. We don't even know what the function is yet, but we know what it looks like, right? Okay, I apologize. I'm going to talk a little more. What does this symbol mean here? You... What just happened?
I'm just having a headache over the exponent.
Oh, I'm sorry. I just like the way you said that. How do I do the of 8? I want everybody to say it that way if you tell them to. Yeah, what's the key root of 8? 2. Now. So I'll take a breath. That's the weirdest reaction to a headache I ever saw, man. I don't know.
I'm scared.
You should be.
She's still going.
I gotta-
We're gonna unlock the
You okay?
Okay.
Do you have questions or are you good?
I'll
No, ask them now.
Are you
Before I get
sure?
too deep into something else.
Can you explain the exponent thing, but like way slower?
I'm sorry, so what you did?
So what you just explained in an hour, explain it in 2 hours.
No, way back. Like,
Oh, really?
the first
What?
time I asked you about exponents and you went through that really, really fast explanation that made sense and then left my head as soon as
Oh,
you started talking.
like this here?
Yeah.
But like the negative also?
Yep.
Okay. Alright. So this is perfect modeling for everybody else. Right? Don't hesitate to ask a question. If you can, preface it with a lot of laughter. And say something like, "You're right!" You don't have to. But it's appreciated. So, if I have this, what do I get?
Yeah.
X squared, is that cool?
Because when you divide things with
Yeah.
exponents, the base.
Because the long ass way to do it is to I lose 3 of them, and there's 2 left, and we went, holy shit, we should just subtract, because that's the definition of subtraction. I had 5, 3 of them went away, that's subtraction. So we literally observed this and said, oh, 5 minus 3, that's just the way it is.
Okay.
That's confusing. I did not make division become subtraction. I didn't say x to the 5th minus x cubed. I said this is how exponents work. When a divide like basis, the power subtract, because that's how many things I'm losing. It's just a shortcut we came up with. Okay. If I do this with the exact same thought process, using the shortcut, what do I get? 2 minus 3?
X with -1.
Yes. 2 minus 3, -1, yes. I subtract powers when I'm dividing like bases, yes. The other way to look at this, though, is this is x times x, sort of like this. How many x's cancel? 2. How many are left? 1. Where? On the bottom. The mistake people make when they do things like that is they say the answer is x. They have to talk to themselves and say it's on the frickin' bottom, me, and put it on the bottom.
Okay, so 1 over x is the same thing as x to the -1.
Yes. In fact, watch this. What do I do to x to the 6th to make it lose an x? You're allowed to do anything mathematically to that, and I want the answer to be x to the 5th.
You have to divide.
Okay, divide by x, correct? If I divide by x, I lose an x, don't I? What about this? What if I multiply by x to the -1? Because what do I do with the powers? What do I do with the powers?
When you multiply them, you add them.
Add the powers. What's 6 minus 1?
X to the 5th.
I get the same damn thing because 1 over x is the same thing as x to the -1.
Okay.
Nice. Now, what I just showed you is not a proof, but it is after you show sort of a proof. This isn't even a proof, but it's good enough. Then you can do stuff like this and go, look, it acts the same way. You lose an x when you do x to the negative 1. You lose an x when you divide by x. So they act the same way. So they represent the same operation. Losing an x. What's up, Dan? Okay. All right.
Okay.
Let me know. All questions are valid.
You can't
Except for
possibly
the bad
be more
ones.
embarrassing than me. I took the cake, so.
What's up?
I said I took the cake for embarrassing, so nobody else is allowed to be embarrassed about their questions.
No, everybody else is really happy you asked. Or not everybody. I can see a few faces like, oh my God. But I mean, you know, this is how this class needs to work. I do not want to steamroll anybody. If I don't get questions, I sort of get into a rhythm. And I just go. And I'll stop every now and again, because thank God I do that sometimes. But if nobody asks questions, so real quick, I'm pretty sure I had this talk with you before. It's not your job to figure out how much time I have to take questions. You with me? I know the pacing. I know what I want to get accomplished today. I know if I don't, I can try to make up, whatever, blah, blah, blah. That's on me. My job is to pace. Your job is to take notes and ask questions, right? So if you are sitting there, see what just happened, and you got a question, at least 4 other people have that question. And you could be their hero if just for one day. There it is. Augie's like, you're not making my headache any better. Oh, it's too bad. It's too damn bad. Little David Bowie never hurt nobody.
Except for the Goblin King, that was kind of a weird movie.
The which one?
Goblin King?
You mean Labyrinth?
Yes.
Yes.
You've seen that?
Yeah, of course I have.
It was a little creepy,
That's
wasn't
a
it?
good movie.
You have homework, Damien.
What?
Yeah, you, Labyrinth. Put that on your movie list.
What's it called?
The Labyrinth.
It's a weird
Yeah,
movie.
Labyrinth.
Hold
Yes.
on, hold on.
With David Bowie.
It kicked so much ass.
Mm-mm.
It's David Bowie. It could have been Michael Jackson. Did you know that?
Really?
They were thinking about Michael Jackson in that role. Which
Jeff, what did you say?
No, that would have been good.
The Time Bandits?
time is time bandits.
Time Bandits.
Oh, and the Mummy. Put
That's
that on
quite a
there.
triple feature there. The
Lab-
Mummy, Time
How do you
Bandits,
spell
and
Labyrinth?
Labyrinth. I
Never
love
mind.
it.
Okay.
By the way, everybody else can watch that if they want to, or not.
And what else?
The Mummy.
Mummy's a good one. Yeah.
The first with Brandon Fraser, the first one?
Yeah.
Fraser, yep.
Yes.
Rachel Weisz.
Oh, it kicks so much ass. That was a nice little intermission. Okay, now just to complete this idea, what is x cubed divided by x cubed? Using the shortcut?
X1?
0, right? 3 minus 3, right? Shortcut is subtract when you divide on like basis, yes.
Equals
But what is something divided by itself?
1.
1. And again, if we do the same thing, what's the only thing I could possibly multiply by and my result is the same as the thing I started with? What's the only thing that does that? 1. But if I multiply by x to the 0, what's 2 plus 0? So this must be frickin' 1. That's not a proof. It's not strong enough for a proof, but it's really frickin' good evidence, right? You'd probably go to jail with that evidence. Get in there, x to the 0. I'm not 1. That was bad. I don't care. I like it. Okay. Is that right?
Yes.
Okay, so coming back to this. This is the graph of the inverse of 2 to the x. That is the graph of the inverse. Guys. Thank you. This is huge because we're about to do something that really trips students up and it kind of, what's the right phrase? Not drives me crazy, but it's something that should not be as hard, but it's understandable. So real quick, remember earlier I got into this. Cube root of 8 is 2, yes? You guys, do you even realize what it is you thought of when I asked you that? Now, some of you guys might sort of have that memorized to a certain point, maybe. So what if I ask you this instead? What if I ask you, what is the cube root of negative 64?
It's like
8i?
4. Oh,
Negative
4.
4. 4i.
No.
It's negative 4.
How do you know it's not 8? Because cube root takes how many of something? Has to break it into 3 parts, right? 8 times 8 is already 64, yeah. But real quick, do you see how you're working with the question that the symbol represents without actually saying the question? Stay with me now. Has anybody ever learned a foreign language?
Right.
Yes. And if you learned English second, I'm sorry. On behalf of English, I'm sorry. We really made it not easy.
Yeah.
Um,
Okay.
when you start to learn a foreign language, you begin by having to translate each word as you go. As you get more comfortable and it becomes, you sort of don't even think about it. So right now I'm not even thinking about what I'm saying, and you can tell at how I'm talking really quickly and I'm barely talking correctly. When you look at like the square root of 16, you guys don't even think about what the shit it's asking you, just know what to do. You don't have to stop and translate. What we're about to do today is we're about to learn the symbol for the inverse of an exponential. The symbol was a bad choice, I will say that now. You're going to have to be very direct with, this is what it's asking me, this is what it's asking me, because it's sort of like learning a new language. I don't know, you know what that symbol means. You don't even have to articulate it to yourself. You just do it. You don't even stop to think, this symbol tells me to. No, just do it. But the symbol we're going to look at today, it's not in there yet. It's like learning a brand new word in a different language. You're like, holy shit, I'm going to have to stop and go, okay, that means this and that means this. I don't know if you guys are with me or not.
You scared me. You started speaking louder. I was scared.
You'll be all right thing. Braden, protect him if I get close. So, what I want you guys to do,
He scares me too.
I kind of want to, I'm going to try something new, which is always exciting. I want you to work on this worksheet, and there's quite a few words, and I want you to kind of follow through it, yes? I want each of you to individually follow through this, and then see if you can start working the problems, and then I'll probably put you in groups a little bit later so you can compare answers. Okay. We'll see how this goes. I am going to come in later, and I'm just going to tell you how things work, just in case this didn't make sense. Maria! Work!
Sure. Why does mine have a couple of logos?
Did you get one? Okay, good.
Logic.